preparations. So let's do that. Thank you.
Okay.
So good morning, good afternoon, good evening, ladies and gentlemen. We are starting the Minamata online session on the review of Annexes A and B to the Minamata Convention in 3 minutes. I see all but one panelist already on board, so I think we can start on time. The last speaker from the European Commission will connect during the session. So I think we can start anytime. So I think I will already start the housekeeping notes. Um, we are going to use the chat box. So if you have if you are likely to ask any questions, please use the chat box and please see where it is. And there may be time for oral questions. The participants are automatically muted, but we can unmute you when we wish you to speak. So if there's any time for oral questions and if you wish to take the floor, please raise your hand. I think you can find the raise hand button. If you have any question, please put it in the chat box. And please note that this session is recorded and broadcasted. Good morning, good afternoon, good evening, ladies and gentlemen. We are starting the first Minamata online session season 3, phase 2. Sorry for this long name. And today's topic is about the information sharing on the review of and amendment of Annexes A and B to the Minamata Convention. So this is the Minamata Online started 3 years ago, and this is what we call season 3. And phase 2 of season 3 starts today, and there's a schedule in front. You see the schedule for the first part of this year on your screen. And the Minamata Online consists of 3 streams. One is the COP5 preparation, of which this is one. And then the second stream, implementation, review, and support. And the third stream, Mercury science. So, and back to this slide. So today, the purpose of this session is uh, to have presentations of the submissions of information on the review of Annex A and B. And we have invited the submitters from European Union, Japan, Uganda, Battery Associations, Clean Lighting Coalition, and Japan Lighting Manufacturers Association. We are and the first speaker will be Japan, and European Union will be the last one because of the schedule of the presenter. So before starting, I like to provide some background on the review of Annex A and B, and why we are going to host this information session. Firstly, the Annex A is about Annex A to the Minamata Convention is about the mercury added products, and the relevant article is Article 4. Article 4 of the Minamata Convention provides that parties shall not allow the manufacture, import, and export of mercury added products listed in Annex A Part 1. The original text of the convention listed 9 product categories, and the fourth meeting of the competent parties in March last year amended Annex A and adding 8 product categories. And also the Annex A has Part 2, which is about the dental amalgam, and the Annex A Part 2 lists 9 measures from which parties shall take 2 of these measures. And also at COP4 or last year, this Part 2 was also amended, and 2 measures, mandatory measures, were added to that annex. So about the amendment of the Annex A that happened at COP4, the, the amendment that was agreed at COP4, and it was officially communicated from the United Nations headquarters on the 28th of September last year, and the convention provides that the amendment will enter into force after 1 year of the date of this official communication, which is the 28th of September this year. So this amendment will come into force on this day, except for any party that has notified the depository in writing that it is unable to accept the amendment text, or for any party that has made a declaration about the applicability of the amendment when the party ratified the convention. Then moving on to Annex B, which is about the manufacturing processes in which mercury compounds are used. The uh, and the relevant article is Article 5. Article 5 of the Minamata Convention provides that parties shall not allow the use of mercury compounds in the manufacturing processes listed in Annex B Part 1, in which two processes are listed, chloralkali and acetaldehyde production. And the same article provides that parties shall take measures to restrict the use of mercury compounds in three processes listed in Annex B Part 2, which is about vinyl chloride monomer production, sodium or potassium methylate or ethylates, or production of polyurethane. COP5 adopted a decision COP4. COP4 took a decision MC4/3 uh, in which it decided that COP5 later this year, which starts in October this year, will consider the phase-out date of 4 product categories listed here, and also consider adding polyurethane production in Part 1 of Annex B. In the same decision, COP requested the Secretariat to compile information on, this about the manufacturing processes listed in Part 2 of Annex B. The Secretariat sent out a letter in April to invite parties and stakeholders to submit relevant information that will contribute to the COP5 consideration by December last year. And we received submissions from Dominican Republic, European Union, Japan, Uganda, battery associations, the Clean Lighting Coalition, and Japan Lighting Manufacturers Association. And this is the background for today. For your information, the same decision also requests the Secretariat to prepare a report on the manufacturing process in which mercury is used, and the COP requests the Secretariat to to reach out to the parties who reported on the existence of such processes pursuant to the Article 21 national reporting, and to learn about whether they continue to use these processes, whether that is scheduled to be phased out nationally, and to what extent mercury-free alternatives are technically and economically feasible. One of the processes, which is the potassium and sodium methylate and ethylates, only two parties, of which one is a regional economic integration organization, and that organization, which is EU, submitted information. So that part of the information is included in today's presentation. So this is my introduction to today's session. And now the, the next part is a series of presentations from the submitter of information. We are asking these presenters to present submission and the information in 10 minutes, and we are going to have a question and answer session after all the presentations. However, if any of you have any questions, please already type it in the chat box so that the presenters may be able to cover such questions during the presentation, or if not, then these questions will be taken up at the question and answer session. So without further ado, I would like to invite Mr. Tamura of the Japanese government to present the Japanese submission. Over to you, Mr. Tamura.
Thank you very much. My name is Hiro Tamura from Ministry of Economy, Technology and Industry, Japan. Thank you very much for giving us time to present the information for Annex A today. As I only have 10 minutes to present today, I'd like to explain the key points only with some pictures. For more information, please read our submission document on the Minamata website. The Battery Manufacturers Association and the Japan Lighting Manufacturers Association will also be presenting technical detail from an expert standpoint later. I hope you will listen to them as well. Next page, please. Okay. I'd like to start by talking about batteries. Major batteries manufacturers have already stopped using mercury. So we can say that the technical and economic feasibility has already been achieved. The Battery Association of Japan, the EU, the US, and the Latin America want to phase out. Benefit of phase out is recycling. It isn't possible to distinguish products mercury-free or not from the external appearance. So phase out is necessary for good recycling. Next page, please. Next, I'd like to talk about LFL from now. There are two alternative methods of LFLs. The first is to replace LFLs with LED retrofit lamps. The second is to replace LFL luminaires with LED integrated luminaires. Luminaires may be a bit of technical term. In some countries, they are called lighting fixtures. LED have a long lifetime and therefore don't need to be replaced, need to be changed. This is a major innovation and generate several advantages for integrated LED luminaires, such as lower cost due to simple structures, higher efficiency, and easier addition of dimming functions. In other words, there is no need to attach a lamp holder to the luminaire for easy replacement, like LFL luminaires. It is expected that integrated LED luminaires will become the mainstream in the future. Considering the higher energy efficiency of integrated LED luminaires compared to LED retrofit lamps, it's better to skip LED retrofit lamp and replace them with integrated LED luminaires more quickly. Next page, please. A detailed explanation will be supplemented later by the Japan Lighting Industry Association, so I will give a brief explanation. According to global market share data, 75% of the luminaires sold are already LED luminaires. A clear distinction must be made between sales and stock in terms of LED replacement rate. Figure 1, left side, shows the percentage of LED luminaires sold in Japan. This is called sales. The red bars are LEDs. The horizontal axis is year. In 2016, more than 90% of luminaires sold were already LED. Figure 2, right side, shows the number of the luminaires already actually installed in house and buildings. This is called stock. The red dotted line shows the LED replacement rate in the stock. It shows 50% in 2021 in Japan. If stock LFL luminaires don't become LED luminaires, LFL will be needed for maintenance. By pre-producing LFL for maintenance, we believe that the phase-out of LFL production can be achieved more quickly. Next page, please. This table compares LED retrofit lamp and integrated LED luminaires. There are compatibility issues with LED retrofit lamps. Some retrofit lamps manufacturers state that any old iron ballast can be used, but this is not true. Manufacturer must show which retrofit lamp can use which LFL luminaires by the list. Figure 3 shows an example of retrofit LED lamp that has caught fire. Figure 4 is an example of LFL luminaires ballast catching fire. To prevent a luminaire side fire, a combination test of the LED retrofit lamp and luminaire needs to be carried out to check the temperature rise on the luminaire side. Unfortunately, it appears that only a few major manufacturers perform such combination tests. Although the cost of integrated luminaires is considered high, the price of LED luminaires can be lower than the price of LFL luminaires plus LED retrofit lamp combined. This is due to the simple design and the lighting circuit doesn't need to make small. Integrated LED luminaires also save energy. Combined with dimming and sensor function, energy saving of 30 through 50% can be expected compared to LED retrofit lamps. Next page, please. Let me summarize my conclusions. LFLs should be phased out. The alternative product integrated LED luminaires, not LED retrofit lamps. The reasons are: number one, LED luminaires are highly compatible and safe. Number two, excellent energy saving performance. Number three, LED luminaires are cheaper than LFL plus LED retrofit lamps. Number four, possible to add dimming and sensor. We say this smart lighting. Finally, I'd like to say an issue that need to be considered when phasing out LFL. LED retrofit lamp can't be used for emergency luminaires or aircraft luminaires. This is because these luminaires also need to have dimming function, and the type of the lamps that can be used are specified in the approvals. In this general lighting, we think we need to create common understanding. If it is not general lighting, no problem. We don't need to phase out such kind of lamps. However, it should be noted that these LFL are same LFL as general lighting purpose. Thank you very much. Finish. Toda-san, I can't hear you.
Hello.
Sorry, I was I was on mute. So thank you for your very good presentation of the very useful technical information, and so sorry for wasting your time, that time you saved 1 minute. So sorry about this. So your presentation was just less than the allotted time. So without further delay, I like to invite Ms. Anne Nakafero of Uganda to present the submission from Uganda. And for you.
Thank you, Eisaku. Good morning, good afternoon to everyone. I'm Anne Nakafero. I work with the National Environment Management Authority in Uganda. Briefly, I wish to thank the Secretariat of the Minamata Convention on Mercury for organizing this information session. I am also going to make a small submission on the amendments of Annexes A and B. So in my presentation, I'll look at the mercury added products, mercury using manufacturing processes. I'll also submit on the mercury waste thresholds and briefly look at the national regulatory framework, which can be able to support the amendments of Annexes A and B, and then I'll conclude. Firstly, our submissions on the amendments to Annexes A and B. Following COP4, we engaged the different lead agencies in relation to the mercury management in Uganda to share information with us regarding the processes that use mercury and mercury added products. This was going to enable us to submit conclusive information towards the amendment of the annexes. Part A under the mercury added products, the justification for the proposal to amend Part 2 of Annex A under the dental amalgam was based on the following. The National Drug Authority in Uganda is in the process of classifying dental amalgam as a drug so that its importation and use is regulated. And this is resulting from the awareness raising that has been taking place. Previously, the dental amalgam was not imported as a drug. And therefore, because of this, we think that the amendments that have been proposed under Part 2 Annex A for the dental amalgam will be able to be implemented. For instance, requiring the importation of dental amalgam in a form that is not in the bulk form will be able to be achieved. There are quite a number of alternatives to dental amalgam in Uganda that include composite. However, they still need to build the capacity of the dental practitioners in their application. Next, please. In relation to the same submission and under mercury added products, whereas the use of thiomazole was not discussed in COP4, we thought it was important for us to also raise it, that the National Drug Authority in Uganda has plans to phase down the importation and use of vaccines containing mercury. So if there's an opportunity at COP4 to bring this on board, it will be very good. Uganda is trying to look at alternatives to vaccines that do not contain mercury, such that manufacturing takes place in the country, and also those that need to be imported are imported. Next, please. Yeah, under the same submission, but this time for mercury using manufacturing processes, that is Part B, our justification for adding the production of polyurethane using mercury containing catalysts to Part 1 of Annex B at COP5 has been justified as follows. Production of polyurethane using mercury containing catalysts is used in a wide range of products in Uganda, and these include adhesives and mattress production. Our concern is that when the products get exposed to ultraviolet light, or if abrasion takes place, mercury is released. It is common in Uganda to find one using a mattress up to when, it is abrased. So it is important for us that this process is discussed at COP5 and that the proposed amendments during COP4 may be adopted. Next, please. This takes us to the second category of submissions on mercury waste thresholds. Thresholds for waste falling under subparagraph 2, part C of Article 11, waste contaminated with mercury and mercury compounds, had our submissions as follows. Firstly, having an international threshold above national or local thresholds may not adequately promote good environmental practices, as manufacturers opt for low environmental investment costs. We have the National Environment Waste Management Regulations of 2020. It has categories of waste to be considered as hazardous unless controlled, segregated, and characterized as non-hazardous. And for this regulation in Uganda, waste containing mercury or mercury added products listed as, for instance, waste containing 0.1% or more by weight of specified mercury products will be regarded as hazardous. And therefore, looking at our threshold, national threshold of 0.1% and the proposed one from COP 3 and all the way to COP 4 seems to be higher than what the local or national thresholds are. Next, please. In relation to the waste management thresholds, again, waste containing 1% or more by weight of any of the following mercury or mercury compounds. For instance, mercury nucleate, mercurous acetate, phenyl mercury acetate, phenyl mercuric nitrate, thiomazole, even waste containing mercury and or mercury added products other than those listed in the previous ones I've spoken about, A and B, are considered as hazardous. And therefore, our justification here is to have a national threshold that is quite low than the local or national thresholds. Next, please. I wish to point out the regulatory framework that would support the amendments of the text in the convention under to support the use of mercury-free alternatives. The National Environment Act of 2019 prohibits the use of mercury in addition to hazardous chemicals regulations to strengthen the law, which are being developed. Of course, this law looks at prohibiting products where alternatives already do exist, and especially in line with the conventions. The Uganda National Bureau of Standards is developing codes of practice for the unlisted mercury products. And Mining and Minerals Act of 2022 for Uganda now classifies mercury as a hazardous substance in mining and has prohibited its use. We are implementing the Planet Gold project, which will develop further guidance documents for implementing the Mining and Minerals Act. So with these regulations in place, we are hopeful that once the amendments are adopted in COP5, we'll be able to align our compliance to that. Next, please. In conclusion, most of this information has been picked from the Minamata initial assessments and, of course, the daily activities of the regulators in line with mercury management. However, there is need to update the inventories for mercury added products and mercury using processes to make informative decisions. In addition, inventories of mercury-free alternatives are necessary, as majority of the agencies that are charged with mercury management in Uganda and probably in the rest of the developing countries have scanty information. Otherwise, the amendments from COP4 regarding the reviews of Annex A and B are justifiable to Uganda, but also we need to ensure that countries are economically ready to go through such transitions. Thank you so much.
Thank you, Anne, for very useful information. And I like to note that the presentation included the mercury waste threshold, but I'm happy to to inform all of you that the expert group on mercury waste threshold met in Geneva last month and agreed on a report, which is already available on the Minamata Convention website. But having said this, thank you very much for that information. And then I'd like to move on to Mr. Sawai of representing the battery associations of Japan, Europe, and Americas. Mr. Sawai, floor is yours.
This opportunity. My name is Michinori Sawai, Battery Association of Japan. I will present Battery Industries Joint Submission on behalf of TWG+. Next slide, please. To begin with, what is TWG+? It's an informal communication group between battery associations in Japan, Europe, North America, and Latin America. We have world-famous household brands. Varta and Rayovac are two giants of zinc-air battery. Maxell, Seiko, Murata, Sony, and Renata are dominant in silver oxide battery. And Panasonic, Energizer, Duracell, and GP are all-round players. Next, please. Let's see availability of mercury-free alternatives. TWG Plus members have ceased mercury use in button batteries. Our products collectively represent 90% of the global market in silver oxide and zinc air batteries. And other makers outside TWG Plus also manufacture mercury-free alternatives. Therefore, there is no problem with availability. Next, please. Here are technical and economical feasibility. From technical aspect, mercury-free technology in button batteries has years of history, and there exist a lot of usable patents. Technical hurdles to mercury-free alternatives are not so high. From economical aspect, mercury-free button batteries are already comparable in price with mercury-added ones. Major manufacturers have completely shifted to mercury-free products. If they had to restart production of mercury-added products, it could cost higher. So, mercury-free alternatives are feasible from both aspects. Next, please. Then, what are environmental impacts? We think button batteries have disposal problem. They are so tiny that consumers throw them away without sorting out from other wastes. As a result, quite a few of them are incinerated with household wastes, leading to mercury emissions into the air. As long as mercury-added button batteries are allowed to exist, this risk continues. Next, please. Moreover, I would like to stress one more thing. This is progress of mercury-free legislations around the world, beginning with some states in America in 2011. European and Asian countries have followed suit. Adding up, 42 countries and/or regions have already banned mercury use in all the batteries without exception. I would like you to notice that they are not necessarily advanced economies. Next, please. Finally, conclusion. TWG Plus proposes as a collective opinion of global battery industry, 1. To put an end to exemption of button batteries. 2. To set threshold of 5 ppm. Minamata Convention does not stipulate mercury containing threshold. We think it's a problem because it allows offenders to get away with the quibble that there is no intentionally added mercury. 5 ppm is a de facto standard of mercury-free threshold, which we believe should be adopted by Minamata Convention as well. Thank you for your attention.
Thank you, Mr. Sawai, and your. I think you're the top runner for the briefness of the presentations. So thank you for trying to make a presentation shorter and for your very useful technical information. So now, without further delays, we are going to move to the next presenter, and we have 3 more presenters. So one is the Clean Lighting Coalition, and then the Japan Lighting Industry Association, and the European Commission. So the next, I would like to turn to Mr. Michael Sholand.
Great. Thank you, Isaku, and good morning and good afternoon to everyone, and good evening for those of you joining in the evening in your part of the world. My name is Mike Sholand from the Clean Lighting Coalition, and I wanted to start by thanking Isaku and the Secretariat for the opportunity to speak to you today. I'm going to speak about saying farewell fluorescent, making mercury in lighting history. Next slide, please. Just a quick note about who we are. The Clean Lighting Coalition is a global partnership that is working to capture the health and environmental benefits from eliminating mercury-based lighting around the world. Our website is here, so please, I encourage you to click on that and get more information about our work. Next slide. And so in response to the Secretariat's invitation to provide data about mercury-added products that were not completed at COP4 and were going to be discussed at COP5, we prepared this submission here. We called it the information document on linear fluorescent lamps for general lighting purposes, and you can click on the link to download it from the Secretariat's website there. We had 6 sections in the report. We start by describing retrofit LED tubes. These are LED tubes that can be installed into fluorescent fixtures without modification. We talk about the compatibility of those LED retrofit tubes, the safety associated with them, the policy progress around the world for many governments who are setting regulations to eliminate toxic fluorescent lighting in favor of moving their markets to LED. I talk about the cost-benefit analysis in the regions there. We have 40 countries that are included in this report. And then we talk as a sort of cautionary note about the risks and the costs of delaying phasing out fluorescent lighting globally. Next slide, please. So let me start by talking on retrofit LED tubes. Much of the information contained in our report is about these, and there are literally tens of thousands of these tubes available all around the world. And they are designed, the circuits in them are designed to operate on fluorescent ballasts in fluorescent fixtures. So it's literally changing the light bulb. You don't need to be a professional to do that. And for our analysis, we reviewed compatibility tables published by the major manufacturers around the world, and we found 91 to 94% of fluorescent fixtures can safely accept the installation of LED retrofit lamps without problems. They do not need to be rewired. And we have a few quotes here from some of the major suppliers. For example, Philips Signify, who are world #1, referred to these lamps as a plug-and-play solution that works straight out of the box. Osram, now also branded as Ledvance, refer to them as a quick, simple, and safe lamp replacement without rewiring. And Tungsten highlights the fact that these LED tubes offer lower system losses while existing fixtures remain intact. So this is a retrofit solution that you can convert to mercury-free and cut your energy use in half, because LEDs are twice as efficient as fluorescent lamps. Now, for that small percentage where the LED tubes are not compatible with the ballast, around 6 to 9%, it is possible to bypass the ballast. So you cut the ballast out of the circuit and bring mains voltage to the sockets for the tubes, and then you simply install an LED tube that is designed to run on mains voltage, and there's plenty of those. So there is essentially no need to change the fixtures until you're ready to do so. Next slide, please. Now, just taking a few words on the safety standards. So the International Electrotechnical Commission, or the IEC, adopted safety standards in 2014, so this is 9 years ago, for double-capped LED lamps designed to retrofit into fluorescent fixtures. And those standards are working. We have literally hundreds of millions of LED tubes installed and in use around the world today. And I just highlight here, there's a brochure in the lower right-hand corner. This is from Philips again. They highlight 100% safe installation, that LED tubes are the fastest and easiest way to upgrade to LED. It is 100% safe and 0% hassle with a simple lamp-for-lamp replacement. So they're making these statements in their literature because it is true. And then I highlight here this company in Finland named Valtalvo, who is going one step further and saying, actually, upgrading to LED tubes improves safety. Because number one, the LED tube, they highlight this in their article, which you can read by clicking on that link. LED tubes use half the power, which means there's half as much heat being generated in the fixture. Fluorescent tubes use more power, hence there's more heat and more fire risk. Secondly, when a fluorescent tube burns out at the end of life, it can be that the filament, the cathodes at the end of the tubes, continue to be heated, and that can result in extremely high temperatures and a fire hazard. And they've done some tests, and they found over 200 degrees Celsius in some of these lamps, meaning the fluorescent lamps, even though it's not working, still are a significant risk. And that problem, they say, does not happen with LED. At the end of life, the LED tube opens the circuit and the starter is no longer heating the lamp. Next slide, please. Now, given the safety aspects, and just like we saw with the Battery Association timeline and global policy, I thought that was a very interesting slide. We're finding the same trend is happening today with fluorescent lighting. So on this map, you can see the regions in North America, in Gulag, in Europe, Asia Pacific, and of course, Africa. There's a lot of movement from policymakers phasing out fluorescent lighting. So each of those hyperlinks there can take you through to the draft legislation or the final legislation, so you can learn more about what's happening in your region. Next slide, please. And part of the reason for this policy progress is governments recognize that there are significant improvements and significant benefits to society from getting rid of fluorescent lighting. And here we highlight that there are 8 Sustainable Development Goals objectives that are met with this by phasing out fluorescent. And there's a link again on this slide. You can click there to find what aspects of these 8 Sustainable Development Goals are being achieved through the phase out of fluorescent lighting. Next slide. So given the strength of the technical feasibility case, I now want to speak briefly on the economic case for phasing out. So this report you see here, and there's a hyperlink again on the slide, is an analysis that we prepared for Bali for the COP4 conference. And we looked at 40 countries around the world where we worked with partners who went into shops and stores and they gathered price information on fluorescent technology and LED replacements. And we basically demonstrated here that there's a very strong economic and technical feasibility case for phasing out fluorescent. And now we are updating this study. We're doubling the number of countries. So in May or June, in the next few months, we will be publishing a report with 80 countries. And it will show, in fact, what we are finding already, that the economic case is even stronger today because LEDs have become less expensive and energy prices have gone up, which means the payback periods are getting even shorter, even more attractive. Next slide. This is an example of the economic analysis you'll find in that report. This happens to be for the country of Brazil, and we compare essentially a fluorescent baseline. So this is a T8, a 36-watt T8 linear fluorescent lamp, and it's being replaced by an LED lamp, which uses 20 watts. And the payback period for this lamp, which is twice the price, in fact, from 15 Brazilian units to 30, the payback period is only 4.8 months. And we're expecting now with the updated data that it will be even shorter than that. This morning when I was looking on a few manufacturers' websites, they just talk about a few months for payback periods. So it's really getting very attractive and very easy to do, switching out away from fluorescent lighting. Next slide. So I just want to park here for a minute and discuss the timing of the phasing out of fluorescent, because this is really what's going to be decided at COP5 by the parties, by all of you who are attending. So if the phase out year is chosen for linear fluorescent lamps to be 2025, the mercury savings, and this includes both mercury from the lamps as well as mercury from the coal-fired power station emissions, because there are significant energy savings associated with phasing out fluorescent. So 198 metric tons of mercury will be avoided being placed into the environment and from 2025 to 2050. So it's a significant amount. In terms of financial savings, 1.34 trillion US dollars saved on energy bills because of the improvement in efficiency from LED compared to fluorescent. And then from a carbon point of view, as you all know, we're facing a global climate crisis. 3.3 gigatons of carbon dioxide emissions will be avoided over that time period. Now, that's if the phase out year is chosen for 2025. Now, if there's a 2-year delay and 2027 is adopted, some of the savings go down. You can see that in the table. So 36 tons of mercury savings will be lost, 220 billion US dollars in energy bill savings will be lost, and around 600 million metric tons of CO2. And if the delay is extended beyond that to 2030, it gets even more significant. So just a call to phase out as early as possible for the maximum benefit. Next slide, please. And I just want to close on a positive note on a hospital in Nigeria, in Lagos, who have said farewell to fluorescent. This is a case study that we worked on with our partner and with the Lagos State Ministry of Health. They upgraded the lighting last year in this hospital. They changed 472 fluorescent bulbs to LED. They're saving 22,000 kilowatt hours per year, which is around 3,000 US dollars on their energy bill. And I learned today that works out to about 1 to 1.5 nurses' salaries in terms of energy savings. So they're able to improve the healthcare and at the same time improve the quality of lighting at the hospital. And that's my final slide. Thank you.
Thank you, Mike, for making all the rich information into a very compact presentation. Please also be informed that the slides will be available on the website, so that all the hyperlinks will be available, although it is already available in the submissions. So then the second to last speaker is Mr. Saito of Japan Light Manufacturers Association.
It's Takeshi Saito from Japan Light Manufacturers Associations. Good evening, good morning, and good afternoon, everyone. Thank you for giving us the opportunity to explain today. I would like to supplement the information provided by the JLMA about fluorescent lamps, mainly the Japanese government's explanation with additional content. The explanation is mainly about LFL, linear fluorescent lamps, and we will also provide information on CFLNI at the end, compact fluorescent lamp without circuit. Next, please. This page shows the Japanese market situation for LFLs. In many areas in the world, the replacement of lamps is done by a professional maintenance company. But in Japan, the replacement is done directly by the users, residents, office workers, and so on. So in Japan, there are 6 different lighting systems for LFLs, as shown in the figure left side. LED retrofit lamps for each type of lighting system use the same base as the fluorescent lamps, and fire accidents have occurred when users have mistakenly installed incompatible LED retrofit lamps. Therefore, the Japanese market has been alerted the replacement of LED retrofit lamps and encouraged to replace them with LED luminaires. Next, please. The GLA, Global Lighting Association, has published the fixture compliance rate for LED retrofit lamps in this table. In the EU, it is the most advanced at 50%, but outside the EU, it is still low. The lighting systems for fluorescent lamp luminaires that exist in different countries and regions are not understood. However, because luminaire types and dependent on the region, LED retrofit lamps need to be tested for safety in combination with the luminaires in which they are to be installed. In response to these safety issues, the working group that developed the IEC safety standard has drafted a document requiring combination confirmation with the luminaires for retrofit lamp replacement, which is expected to be established by the end of 2023. Next, please. This page shows the status of LED lighting luminaires in the Japanese market. The graph above shows the annual sales volume of LED luminaires and conventional luminaires sold in Japan. The use of LED lighting is very advanced in Japan, and more than 90% of sold luminaires after 2016 are already LED luminaires. Below figure, the dotted red lines shows what percentage of the luminaires already installed in homes and buildings have already been converted to LED luminaires. In the Japanese market in 2021, there will still be 50% of conventional luminaires left in the market, and the number will be about 900 million. Since the Great East Japan earthquake in 2011, the spread of energy-saving LED luminaires has progressed, and 50% of the luminaires have been converted to LEDs over the past 10 years. We are promoting the replacement of 50% of these existing conventional luminaires, or 900 million units, with LED luminaires, with the goal to converting to LED luminaires in 7 years by 2030. Next, please. In addition, we estimated the period required for replacement in consideration of the number of installed LFLs luminaires and the production capacity of integrated LED luminaires, which are alternative products in the entire global market. According to the global market report, stock of existing lighting luminaires is 16 billion, and the sales of LED luminaires is 1.8 billion, and sales volume of LED lamps 2.8 billions. Stock of existing LFL luminaires numbers, sales numbers of LED retrofit lamps for LFL, and the sales numbers of LED luminaires as substitute for LFL were estimated based on the actual data of the Japanese market. It will take approximately 12.5 years by LED retrofit lamps and 7.5 years for replacing by LED fixtures. So the replacement with LED luminaires is more suitable. LED luminaires is more suitable for the environment due to the reduction of CO2 emission in combination with mercury reduction, as LED luminaires can save more energy than retrofit lamps through appropriate lighting control and dimming according to the lighting using environments. For more information, please refer the annex of the information materials. Next, please. We also provided information about CFLNY for reference. About compact fluorescent lamps, no controller, CFLNY luminaires, CFLNY has more than 80 type products groups. Therefore, there is no safety standard for LED retrofit lamps compatible with CFLNY. For CFLNY, it is realistic to replace with integrated LED luminaires. According to trial calculation, the period required for replacement worldwide is 8.6 years. We believe it is appropriate to replace retrofit lamps with LED fixtures. Please investigating the actual situation of the market in each region or country and consider the period required for LED replacement. Thank you for your attention.
Thank you, Saito-san, for the very good technical information. And I note that there are some questions and comments in the chat box, so I encourage all the participants to use the chat box for the question and answer session. So with this, I'm going to turn to Ms. Jenny Green of the European Commission to present the submission from the European Union. Jenny, you have the floor.
Good morning, good afternoon, and good evening, everybody. I hope you can hear me. And thank you for allowing me to speak to the EU's submission, mostly concerning mercury-added processes. So in accordance with Decision 4.3 on the review of the amendment of Annexes A and B to the Minamata Convention, the COP4 requested parties to submit information to the Secretariat on 2 manufacturing processes using mercury and mercury compounds. And specifically, the COP requested information on whether parties continue to use the 2 manufacturing processes for VCM and the production of sodium, potassium methylate and ethylate, and whether there are schedules to be to phase these processes out, and to what extent mercury-free alternatives are technically and economically feasible. So under EU law, the use of mercury and mercury compounds in manufacturing processes is addressed under the Mercury Regulation in its Articles 7.1 and 2 and in its Annex 3. So the production, in practice, this means that the production of VCM has actually been prohibited in the EU since the 1st of January 2022. And the production of sodium, potassium methylate or ethylate will be prohibited from January 2028. And the production of sodium, potassium methylate and ethylate shall be carried out in accordance with certain conditions under the Mercury Regulation. And these include not using mercury from primary mercury mining. It means that direct and indirect releases of mercury into air, water, and land in terms of per unit production need to be reduced or had to be reduced by 50% by 2020 compared to 2010. It requests supporting research and development in respect of mercury-free manufacturing processes. And as from June 2017, the capacity of installations using mercury and mercury compounds to the production of sodium, potassium, methylate, and ethylate that were in operation before that date shall not be increased, and no new installations shall be allowed. So the EU has submitted to the Minamata Secretariat in 2020 information concerning technical, economic, and environmental feasibility of mercury-free alternatives of a whole range of mercury-added products, but also includes mercury-free alternatives and information on mercury as a catalyst and an electrode. I keep it very short today. Thank you very much for your attention.
Thank you. Thank you, Jenny. And so sorry for not being able to to scroll the slide as you spoke. I hope that the presentation was clear to all the participants. So and now thanks to the efforts of all the presenters to keep to the 10-minute limit. I think we have almost 30 minutes of the question and answer discussion session, which is great. So we may have a time for oral intervention questions, but I like to start from the chat. I think there are 3 sets of comments. One is from Raj Ratamano. Ballast of old LFA fixture contain PCB. Retrofitting these old fixtures with new LED fixture is the most preferred option. Just a thought. So I think this is not a question to the presenter, but and also Raj has left, but I think this may be a valid point. From Lisa Matriste, thank you, panelists, for your enlightening presentations. I especially appreciated compelling case for an early phase out of fluorescent lamps put forward by Michael from Click. I would appreciate comment on to identify what might be the potential obstacles presented by the parties at COP5 for not adopting the early phase-out date of 2025. And before going to the next question, perhaps since we already see Michael, Michael, do you want to say something on this?
Sure thing, Isaku. And just for anyone on the call who is interested in the question from Raj, I can say a few words about that. I actually have a PCB ballast right here in my hands, which was in my kitchen here in London. 60 years old, this thing was. It's been in service a very long time. And it is a magnetic ballast. So this is a line frequency ballast. And LED retrofit tubes are 100% compatible with those. So it would be super simple to take out the fluorescent and put in an LED retrofit. And the thing is, it is expensive to change fixtures. And it can be, for some businesses, a problem and a barrier. So they can benefit from the savings right away by retrofitting the LED tube, get lower bills, get short payback periods, and then save up for the upgrade of the fixtures to LED fixtures. That is definitely the end game. And getting rid of PCB contaminated ballast is another co-benefit, really, of this initiative. Regarding Lisa's question, I don't see any obstacle at all. Now, I am an NGO, right? I'm following the policy developments around the world, and we're doing market analysis and technical analysis, and you can see that in our submission. I please encourage you to take a look at that. There's a lot of good information in there, but really we don't see any obstacles given what's happening with policy developments in other parts of the world. So really a global phase out through Minamata would augment and accelerate those policy developments. So I think it would be a very positive thing to see an ambitious 2025 phase out date at COP5. Thanks, Isaku.
Thank you. Thank you, Michael. So, and I'm very glad that we have more questions on the chat box from Warfeta Murshed. Thank you, panelists. It was highly informative. I would like to know how we can involve countries like Bangladesh to be part of the amendment, and how can youth be part of the entire process. And if I may respond as from the Secretariat point of view, it is up to the parties who to propose amendments and also take part in the decision making at COP. So it is very important that the national process for decision making involves the the various stakeholders, and also the Minamata Convention Secretariat is convening some several brown bag sessions with about the NGO involvement. So NGOs are part of the COP process as observers. So and we very much look forward and encourage the youth group as well to be part of the COP process through being an observer. From Ms. Mariko Arikawa to I think this is to the Japan Lighting Manufacturing Association. In my research, JLMA data on the production of fluorescent lamps and other lamps shows the possibility that its production will be finished naturally by almost 2025. And the Clean Lighting Coalition speaker indicated that the world is making very good progress phasing out mercury-containing fluorescent lighting. With the 27 countries of the European Union, as well as the countries in the European Economic Area phasing out in August this year. I am a Japanese and am concerned about the target year to eliminate fluorescent lamps proposed by JLMA is 2030, and by Japan is 2027. Both of them are behind 2025. Could you please give me a rational reason for why Japan makes a proposal to delay the world's a proactive attitude despite Japan having the concrete feasibility of phase out? One more question. I saw that comment in the JLMA submission to the Secretariat. I found it very confusing because 70% of these fires reported by the Consumer Affairs Agency of Japan are about general service lamps, not the LED tubes shown in the picture of the JLMA comments and the Japanese government's comment. The truth is that only about 10%. This is the average number between 2019 to 2021 of these fires were due to LED retrofit tubes, far less than you are claiming. I would like to ask you to elaborate this on this point. Lastly, I can see that the Japanese lighting industry has not adopted IEC International LED retrofit lamps like all other lighting companies in the world, and this causes far delay of Japan's shift to LEDs. The other countries in the world do not experience problem like Japan because IEC safety standards work, and that's why their government can phase out fluorescent lamps. I want to know why can Japan adopt international safety standards? Sorry, it is quite challenging to read it because it's moving. Sorry about this. So that we can benefit from mercury-free direct drop-in retrofit too, and then at least we can be mercury-free until such time as all the fixtures in Japan to be replaced with dedicated LED retrofits. That is better solution for everyone, people and industry. Yeah, I think I will stop and perhaps see whether the Japanese colleagues, whether JLMA or the Japanese government would like to respond. It is not our intention uh, to point to any parties or any organizations, but if we can make any good some information to in relation to this question, it may be helpful. Is anybody willing to?
Thank you for Secretariat. Saito speak for JEMA. I explained that in Japanese market is users replacement lamps. So in Japan, LFL retrofit LED lamps is not used. So LFL lighting fixtures exchange, we recommend it. So the sales number of the LFL fixtures, so less than 50%, about 900 billion market to fixtures exchange is that 7 years we need. That's all. Okay.
Thank you, Saito-san. And then I will move on. I think Mr. Leon Konings provided some explanation about the challenges in LED retrofit. Since we are that we are receiving many texts, I'm not going to read it aloud, but there's a comment from Leon and from Mike. There's Mike, you responded to the question. Also, Michael Musenga Thank you for this invitation. Can we have general agreement to all nations, especially that all governments sign the treaty? NGOs a lot of time to try and advocate for the enforcement. Thank you for this comment, and we are from the Secretariat as well. We are trying our best to support the parties to implement the Minamata Convention, including the phase out of the agreed and added mercury products. So, okay, so perhaps, yeah, I think we have covered all the written questions, but perhaps since Mike, you are the last one who put the message in the chat, perhaps you wish to speak on this debate.
Yeah, I don't think it's a debate. I was surprised to learn here that Japan doesn't follow IEC safety standards. I know Japan is a full member of the IEC, and this safety standard that I mentioned has been around for 9 years. Leon Koenigs works for Signify, for Philips, is the world's largest manufacturer. Today he's representing the Global Lighting Association, and he's highlighting these compatibility percentages, which are a little different from the literature that I've reviewed from his company. So that may be something Leon and I need to have a discussion about separately, because I used his literature as in my analysis, where I calculate the 91 to 94% compatibility. So that's something we can discuss separately. But I do think, as I said in the chat, maybe the Global Lighting Association should meet with the Japanese Standards Association and see if there's a way they can fast track adoption of the IEC retrofit standard for retrofit LED tubes into fluorescent fixtures. I honestly think that could make things a lot safer and enable Japan to move faster towards mercury-free, more efficient lighting. Thank you, Saku.
Thank you, Mike. So, if any of the panelists wishes to speak, you can just unmute yourself. And while waiting, I'm looking at the chat box, but there's no additional question.
Excuse me, may I speak?
Yes.
I'm Hiroyuki Matsuda from Japan, Ministry of Economy, Trade and Industry.
Yes, please, Machida-san.
I'm afraid that there is a bit confusion about adopting IEC international safety standards. I believe that the Japanese LED industry is using such IEC international safety standards, but the safety points for not sparkling fire in adapting retrofit lamp is not not for only adapting IC standards for LEDs itself. The compatibility of the combination are essential. So to check such a compatibility of the both for fluorescent luminaires and fluorescent lamp plus LED retrofit lamps has a large number of has a possibility of large numbers of combinations. So the risks to spark the fire, it depends on each combination of the fluorescent luminaires and LED retrofit lamps. So the to use retrofit lamps safely, so each test should be needed. That's my understanding. Is it
Thank you.
Answer to your questions?
Thank you very much, Machida-san. I think, yeah, this question may have a bit of bigger background about the safety registration system in different parties. So I'm not sure whether this can be solved now, but perhaps I would encourage some bilateral conversation, and we would be happy to help. I see one raised hand from Leon, and I think it was trying whether we can invite him to speak. Leon, do you?
Yes, can you hear me?
Yes, I hear you now.
Oh, thank you for giving me also the opportunity to react. It is much more complicated than which is just mentioned, but I try to focus on the headlines. The compatibility of a lamp depends on which electronics is used inside the fixture, and the safety standard says that a manufacturer should make a lamp safe for all electronics inside. But that means that you need, as a manufacturer, to test all the electronics which is available in the market. And what responsible manufacturers do is that they include inside their lamps safety elements which would avoid nasty effects like fire. But sometimes the fire can happen inside the driver, because in the driver there will be too much currents, and that then the manufacturer cannot affect that. But then responsible manufacturers protect their lamps, but many others do not do that, especially the cheap manufacturers. And then we will have a big problem in the market by exchanging these lamps and that's why we as manufacturers say, yes, it's easy replacement, no hassle, you can use our lamps. But be careful, you have to check the list of drivers where we tested the lamps with. And that list is also available on the websites of responsible manufacturers. And that's only a limited list, because there are thousands of electronics inside luminaires in the world, and we tested only a few hundred, let's say, or 100 or 200. And that is the big problem of LED retrofit lamps. So the lists which we made on our websites show that the compatibility is 50%, not with respect to safety, but with respect to flickering, with respect to that it's not cannot be used for emergency luminaires because of an IEC standard. It cannot be used for DC operations. It can sometimes give audible noise with some drivers, and even EMC with some drivers. And that all together results in a compatibility in Europe with 50% of the installed installations. And as a GLA, we did a survey for other regions, and other regions it's much lower. And but it's more related than to other elements like flickering and that the lamp cannot work, because you have several types of LEDs, and for a normal consumer it is not easy to pick the right lamp, because you will try it and then you will find out that it does not work, or it gets too hot and it will only function for a few months and then it will break, or it will flicker and he goes back to the shop and he has no clue how to solve it. That's why we promote that professional installers should be included in this change process. And Europe mainly did those changes in offices, and that is already done by professional installers, and they know the problems and they can handle that. But consumers, we are afraid that they cannot really handle that. Thank you.
Thank you, Leon. So we have, and thank you, Mike, for putting your information on the chat.
Yeah, Isaku, I just added, sorry, just quickly for the context for those last two speakers. So for Mr. Hiroki, I've put in there the specific IEC safety standard that I referred to. So if you can check and see if the Japanese Standards Association is following that one, that's the one in particular. I had found a business roundtable meeting where the European Union had met with the Japanese government and asked them, and this was in 2015, so it was the year after the standard was published, asked them specifically to follow this standard. So hopefully that's happened, but that's the specific one which is important for the retrofit lamps. And then to Leon's point about compatibility, I just pasted there in the chat a link to the database. So that's Isaku and the team at the Secretariat posted that there last year. So you can have a look at that. And there's over 600 ballasts in there for T5 and T8, showing which lamps from which manufacturers are compatible. And as Leon says, they've tested with as many as they can, and they continue to do testing. But when you look at those numbers in the EU market, you're well over 90% compatibility. And part of that is because of this ballast I showed earlier, the magnetic ballast, which is the most durable one, which survives in humidity, which survives power surges, a lot of the tough conditions that ballasts have to cope with in emerging markets. LEDs are 100% compatible with those. You just change the starter and you pop in a choke ballast, a magnetic ballast compatible LED lamp. So that's the easiest upgrade to do, frankly. Thanks, Isaku.
Thank you, Mike. So we have 3 minutes left, and I don't see other hand or any other point in the chat box. So unless any of you wishes to speak, I'd like to try to close this session, and I'm not going to summarize the session. This is just an information exchange session, and I'm very happy that some technical interaction was made orally and through the chat box. This was very helpful, I think, and we look forward to the consideration by the competent parties on the amendment proposals that were forwarded from COP4 to COP5. So having said this, thank you very much for all of the participants and especially to all the panelists who presented the very helpful information. Thank you very much, and have a nice day, evening, night, or whatever, depending on where you are. Thank you very much. Bye.
Thanks, everybody. Bye.
Bye.
Thanks.